So welcome to everybody who's joining on. Thank you for joining us this evening. We're just waiting for the rest of our attendees to join on tonight, and we'll get going in just a few moments. So while you wait, go ahead and jump on over into the chat and let us know where you're joining from tonight. Give us your city and your state. We always like to see where you're coming in from. So hang on just a few more minutes as people join in. Right, I have a question, SJ. I can't, unfortunately, change your name on here, but I got you. You may be able to change it. If you look at the change name feature, there should be 3 dots. You might be able to change your name on your end. I don't know that that's something I can do. We got lots of folks joining. Gold Canyon, Buckeye, Phoenix, Gilbert, more Phoenix, more Gilbert. We got folks from all over. Thanks for joining us tonight. If you're just tuning in, we're just letting other folks join on. And while we're waiting, go ahead and let us know where you're joining in from. I see folks from Mesa and Tucson. Good evening. Thanks for joining us tonight. We have a question about some of the other recordings from this particular series, the Astronaut Virtual Series from Arizona Science Center. So we had Kelly Girardi, and we had some folks from the Boeing company talk about Starliner, and those are both available on YouTube, the Arizona Science Center's YouTube channel. So by all means, jump on there if you missed those. We have one of our viewers asking for the passcode, and unfortunately, I don't know what the passcode is. You should have gotten all the information with the link when you registered for the talk. So if you've got somebody that's trying to log in, you can send them the registration link. They can register now, and they'll get that email sent right to them with the Zoom link and any information they need to log in. Sorry that I can't be more helpful there. All right, I have a feeling we have a lot more folks who are going to be joining on as we get going here, but I know it's almost time for 6, so we're going to just get started here. So welcome again to all of you for being here tonight for our Astronaut Virtual Series. I'm Sari Custer, Chief of Science and Curiosity at Arizona Science Center, and I'm going to be your host tonight. I'm thrilled to welcome you to our final installment of the Astronaut Virtual Series, made possible by generous support from the Richard F. Karras Charitable Trust. So we thank them very much for all of their support in making this happen. This entire series has been about finding dynamic ways to connect you with experts in space exploration from a variety of different backgrounds and doing it in a unique way that ties into our special exhibition, Astronaut, which is an interactive exhibition all about letting you investigate the reality of physical and mental challenges that go into becoming a space explorer. Now, Astronaut's only open for a few more days, so now through Memorial Day. So check it out if you haven't already seen it. And you can also catch our giant screen film, Astronaut Ocean to Orbit, which explores how astronauts train underwater to get used to microgravity. So another really interesting opportunity. And also, before we get to today's amazing special guest, I can't wait for you to have our special guests on. Just a little bit of housekeeping. Likely this isn't your first virtual event, but just in case, please feel free to communicate via the chat. You'll see that at the bottom, and then it's going to pop up over on the right. You can express all your feelings, ask questions in there to other folks. But also, we're going to use the Q&A function for our questions for our special guest today. So at the bottom of your screen, you see a little chat bubble that says Q&A. We're going to use that feature so that we can keep track of all your questions. So please put them there. You can also upvote questions in that section. If you see something that you really like and you're like, oh, that's a good question, I want you to ask that for sure. Go ahead and hit the like button and upvote it so that we know that that's the one you want us to ask. And that becomes especially helpful as we get down to the end of our time today. All right, so now on to our main event. Tonight, I'm beyond excited to introduce Dr. Jim Bell, joining us from Arizona State University right here in Arizona as our final speaker in our series. Now, Dr. Bell is a professor in the School of Earth and Space Exploration at Arizona State University in Tempe, Arizona, an adjunct professor in the Department of Astronomy at Cornell University in Ithaca, New York, and a distinguished visiting scientist at NASA's JPL laboratory, JPL in Pasadena, California. Jim's an active planetary scientist and has been heavily involved in many NASA robotic space exploration missions, including, all right, get ready for this list, you guys, Near-Earth Asteroid Rendezvous, so NEAR, Mars Pathfinder, Comet Nucleus Tour, Mars Rover Spirit, Opportunity, Curiosity, and now Perseverance, Mars Odyssey Orbiter, Mars Reconnaissance Orbiter, and the Lunar Reconnaissance Orbiter. That's a list. Jim was the lead scientist in charge of the panoramic camera, PanCam, the stereoscopic imaging system on Spirit and Opportunity rovers, is the deputy principal investigator of the MASCAM camera system on the Curiosity rover, and is the PI for the MASCAM Z cameras on Perseverance. Whew. All right, I'm still not done, but I think it's really important to note all this. Jim, you're also an educator, author, public speaker, president of the Planetary Society. In 2011, you received the Carl Sagan Medal for Excellence in Public Communication from the American Astronomical Society. And at ASU, you run a variety of different research programs. So I don't know when you sleep. And I'm also going to add that, Dr. Bell, you've been an advisor for us for our NASA grant for several years now, which is coming to a close very swiftly here. And you're just generally a nice human being. I really enjoy that.
Sarah, you forgot the most important thing. Member of the Arizona Science Center. That's
Member of the Arizona Science Center. Yes, absolutely. I mean, I do have to share that that is a really important feature. But we're so happy to have you tonight, and I want to kick it over to you to be able to share all of your great knowledge with our guests tonight. So thank you for being here.
Thank you. So I love the Science Center. It's great to be part of this. Did you say you were like Chief of Curiosity? Is that your job? That's awesome.
Yeah, Chief of Science and Curiosity at the Science
Science
Center.
and Curiosity. That is excellent.
Curiosity.
I want a title like that someday. That's really super awesome. Sarah, thank you so much. Thank you to the Science Center for inviting me to talk today, and thank you everybody who's dialed in. I wish we could be in person and I could see if you laugh at my jokes or not, but anyway, I'm glad we can get together in some way, and I want to share with you, and I'm also happy to be part of this virtual astronaut series, because I feel like we're all going to be virtual astronauts. I'm going to take you all on a virtual trip, a virtual tour across the solar system. This talk is based on a book I wrote a few years ago called The Ultimate Interplanetary Travel Guide. And it is kind of what it sounds like. It's like you'd go and get a travel guide to go to Europe or Tahiti or something like that, except that it's set 200 years in the future, and you're thinking about traveling off planet somewhere else. So let me start my so I got to try to reproduce this, Sarah, if I can. Portion of screen, right? Share. Tell me if that's working.
You don't even need my help. All right.
Is it working?
It is.
And you're still hearing me? Yes. Okay, good. Yep. Okay, so we're going to transport ourselves 200 years in the future, and talk about what kinds of space tourism we could be doing. And this is. You might think this is science fiction, but I actually believe that this is really going to happen. I don't know if it's going to be 200 years from now, 100 years from now, 50 years from now. It's not next year, but I think this is the future that's coming. And I want to start it off. Actually, I like to start this talk off with a short film that was made by a Swedish short filmmaker, Eric Vernquist. And I saw this film. It happened to come out around the same, it's only a few minutes long, happened to come out around the same time that the book came out. And I wrote to him, I said, that's spectacular. I'd love to use this because it really sets the stage for that future that that I'm imagining that I want to take you to. So let me run the film here and enjoy it.
For all its material advantages, the sedentary life has left us edgy, unfulfilled. Even after 400 generations in villages and cities, we haven't forgotten. The open road still softly calls, like a nearly forgotten song of childhood. We invest far-off places with a certain romance. The appeal, I suspect, has been meticulously crafted by natural selection as an essential element in our survival. Long summers, mild winters, rich harvests, plentiful game. None of them lasts forever. Your own life, or your band's, or even your species might be owed to a restless few drawn by a craving they can hardly articulate or understand, to undiscovered lands and new worlds. Herman Melville in Moby Dick spoke for wanderers in all epochs and meridians. He said, I am tormented with an everlasting itch for things remote. I love to sail forbidden seas. Maybe it's a little early. Maybe the time is not quite yet. But those other worlds, promising untold opportunities, beckon. Silently, they orbit the sun, waiting.
Nothing gets your space juices flowing like a little Carl Sagan, right? Pretty spectacular. And the thing that I like best about that film is that every place in that film is a real place in the solar system. It's not made up. It's not from some Hollywood set or some graphics designer. It's a real place in our own solar system. And all Eric did was he put people there. And that's the future that I'm talking about. All right, so you've decided, finally, you and your partner, your spouse have decided, let's take that long-awaited trip off planet, where we're going to go, next summer, next year, whatever. Okay, well, you got to start thinking about preparing, just like if you were to go to South America, Antarctica, Europe, whatever, you got to prepare, right? It's a different environment. Except what you're preparing for is an extremely different environment, the off-planet environment. You might be dealing with low gravity, you might be dealing with high gravity, you might be dealing with super hot temperatures, super cold temperatures, high atmospheric pressure, no atmospheric pressure at all, radiation, rugged terrains with no roads, super long travel times to get out to these places, unlike any airplane flight that you could take on our planet, okay? But then in order for there to be space tourism and for there to be a market for that, there have to be things to do, right? There's going to be natural attractions to see out there. And one of the points I'll try to make in this talk is that I think we already know where the interplanetary national parks are going to be in our solar system. We've done enough reconnaissance in 50 to 60 years of NASA and other space agencies to know where the most spectacular sites are to be seen and photographed and hiked and experienced in our own solar system. And that's a pretty cool thing. Those are going to be the attractions of the future, the natural attractions. But there's also going to be infrastructure there: hotels, transportation systems, restaurants, bars, clubs, sports venues. There will need to be things to do to support a tourist industry across the solar system, just like there are things to do to support tourist industry across our own planet. And people looking for a business model to support more people going out into space, tourism is a great business model, right? It's a super effective business model here on the Earth to encourage people to travel and experience other parts of their country or their planet. And I think that same model will apply to outer space as well. So you got to have to deal with all these things, and there'll be trained professionals, just like in the tourism industry on Earth, trained professionals to help you figure that out. Because if you don't know how to use the spacesuit the right way, you're going to get hurt or perhaps even die. If you don't have a trained professional who can pilot your spaceship the right way, you're going to be in trouble. So there'll be people working in that business sector, in that service industry, on behalf of tourists of the future as well. All right, maybe you just want to go somewhere for the weekend. Where better to go than our own moon, right? What could you do at the moon? It's right here, it's right nearby. Maybe you're a fan of space history. You can tour the historic landing sites. You can visit the historic polar ice mines of the moon. There's ice at the poles of the moon, buried underground from ancient comet impacts that have crashed there and deposited ice across the surface, and the sun never rises in some of these deep craters, the lunar poles. It never melts that ice. You can go hiking on some of the most incredible dramatic mountain hiking in the solar system. You can go to a low gravity theme park, right? You can do sports in low gravity. You want to hit a driver golf ball longer than ever before? Well, you can do that on the moon, certainly much longer than you could on the Earth because of the lower 1/8 gravity. Lots of probably unique cuisine coming out of that particular taste of that soil. Imagine Brussels sprouts from the far side of the moon. You must have that certain, I don't know, I can't quite place it. But they will, all of this will be out there. And especially for historians, or fans of the history of space exploration, go and see Neil and Buzz's footprints and the first early Soviet landers and the rovers that are on the moon, and visit the places that the astronauts visited first in the late 1960s and early 1970s. Except they could only go so far. You can go farther than they will be able to go. But these are historic sites that will be on the moon, that they are already designated as United Nations historic sites, and they'll be great tourist destinations. There'll probably be a felt rope around them, so you can't go and trash Neil and Buzz's footprints. They're protected, so just like some protected historic sites and areas on the Earth, they're treated that way already, and there are special protections for them. But they will be tourist attractions in the future. Amazing geology, lava tubes and caves you can go into, mountains you can climb that you would never be able to climb a 20,000 foot mountain peak on the Earth unless you're really ready for it, really in shape, take the precautions, do the preparations, hire the guides. At 1/6 to 1/8 gravity, much easier to do on the moon. So lots of lots of cool opportunities. So travel times, relatively short, technology is getting better, propulsion technology getting better. Maybe you can get there in less than a day. It takes like 3 days now. And so you can really think about taking a weekend vacation on the moon. Maybe you want to wait for a long weekend, like the one coming up, but that's going to be possible in the future. Let's get out of the Earth Moon system. Let's go to Venus, right? What's there to be to do on Venus? A super hot environment, thick atmosphere, temperatures at the surface hotter than your oven. So a difficult place. Technology is going to have to solve the problem of getting into that environment, and especially down onto the surface. High pressure, high temperature, clouds of sulfuric acid that you have to descend through to get down to the surface. But down on that surface, again, fans of the history of space exploration will find a whole bunch of Soviet spacecraft, French balloons, US missions that have gone there and orbited that planet, and an amazing array of geologic structures, volcanic structures like on the Earth. Venus is shrouded in clouds, but it's clear down at the surface, 800 degrees down at the surface, so you have to be prepared for that. The spaceships that have gone there, very kind of, industrial strength, heavy rivets and metal, and to survive that crushing atmospheric pressure, 90 times the atmospheric pressure of the surface of the Earth. So an option might be to just go up high in the clouds. High in the clouds or above the clouds of Venus, there are shirt sleeve environments, temperatures that are comparable to on the Earth. You need to have something to breathe, bring some oxygen, don't forget that. But very comfortable environments from which these sort of air hotel kind of concept that I imagine could be floating up there. And that would be your stepping off point to take a specially engineered vehicle or sets of vehicles down to the surface to experience it down there. It's a harsh environment, but it's just engineering that needs to solve that problem. The problem has been solved for deep sea exploration on the Earth, not the high temperature, but the high pressure. So similar kinds of high pressure capsules, but with great cooling systems would be needed to get down under the surface. This is a projection of a picture from the Magellan mission, the radar mission that mapped the surface of Venus. We know there are big volcanoes down there. We know there are lava flows. We haven't found evidence that they're truly active volcanoes yet, but that evidence will come, and it will exist in before 200 years from now. It's very much a planet like the Earth, same size as the Earth, same age as the Earth, same basic composition as the Earth. So there's every expectation that Venus has active volcanoes like the Earth does. It's just a matter of time until we discover them, and they will be great places to go visit for amateur geologists or just people who want to see amazing landscapes and brand new lava flows like you could get in Iceland or Hawaii, but here on another planet. Even farther in towards the sun, maybe you want to get some sun, maybe you want to literally get some sun, maybe you want to take a little vacation to visit the sun. The sun is our star, right? It is the center of our solar system. It is most of the mass of everything in our solar system, and it is an average star, but it means everything to us. It's the source of all light and heat and ultimately life on our planet, perhaps elsewhere in our solar system. And wouldn't it be cool to be able to take a cruise, basically, to get close to the sun, to look at some of those amazing structures on the surface of the sun. We can only see the atmosphere of the sun during solar eclipses. This beautiful picture of a solar eclipse shows the magnetic field lines of the sun and these swirly vortices and all that. And you've seen pictures perhaps from satellites that are designed to study the sun at X-rays or ultraviolet light. And there are these beautiful loops, prominences, and flares that come off the visible optical surface of the sun, and just an amazing sight. Each of these, this little dot right here is about the size of the Earth, right? So these are enormous structures, and wouldn't it be cool to be in a ship specially engineered for the radiation, for the heat, to dive through some of these beautiful coronal loops? Extremely dangerous. You'd have to sign some forms. Your lawyer would have to be involved. That absolves the company of any liability. So it's kind of adventure tourism, but boy, what an adventure that would be to see our own star up close and personal, that close, right? Okay, maybe you've got some more time. You want to go farther out in the solar system. Maybe you want to spend your summer vacation on Mars. This would be great for teachers, right? You get the summer off. Hey, what are we going to do for 2-3 months? Let's go out to Mars, right? Technology will hopefully allow us to travel there more quickly than we have been able to do. Actually, you know what? I don't, Sari, I don't have any other movies in the presentation, so I'm gonna switch to full screen mode because I want to get back to my transitions. Just hang on with me here for a second.
All the joys and flexibility of virtual presentation.
Yes,
you can just
yes.
it right
because I want to use these. I like these transitions here. Are you seeing my full screen?
Funny enough, I don't think anybody can tell the difference of the full screen and before.
Okay.
So yes, we can see
good.
it.
Good. Okay. So you want to go to, maybe you want to go to Mars. What is there to do there? There are going to be settlements. There are going to be cities. There's going to be people living on Mars. It could happen. It could easily happen in our lifetimes. The first settlers who go, but over the next few centuries, it's going to start becoming a real popular place. There are amazing sites and geology and Earth-like hikes and mountains and ancient river valleys without any water in them anymore. Polar caps of ice, water ice and dry ice, CO2, historical landing sites of landers and rovers, many successful, many not, that can be visited and experienced firsthand. We can think about special sporting events like Winter Olympics on a planet with lower gravity. Again, the stadiums would be different. The rules would have to be different for the human body designed for Earth. And of course, as people are born on Mars, the Mars human body is going to diverge from the the Earth human body. And that's going to be interesting to see what happens in the future. Let's see if I can, I'm getting them. There we go. So lots of places that we've studied on Mars with landers and rovers, and these are all future tourist attractions, of course. The tallest volcanoes in the solar system, extinct, unlike those on the Earth and most likely Venus, but still enormous and spectacular structures, amazing deep canyons. The largest canyon system in the solar system on Mars dwarfs the Grand Canyon in Arizona for scale. Again, spectacular photography, hiking, geology, landscapes, and amazing polar caps that have these beautiful layers that preserve the ancient climate history of Mars. If we want to understand how Earth's climate is changing relative to the climates of other planets and what the climates of other planets can tell us about our own, here's the record of climate stored in the ice layers of the Mars polar caps, just like the Earth's record is stored in the ice layers in Antarctica and Greenland. So scientific research, of course, happening in these places. And then you saw from the film this idea of lighter than aircraft taking people around to different places. And one of the places you might visit might be where the Perseverance rover ends up. The mission is going great. We're in not more than 90 days now in the mission at ASU in Tempe. We're leading the team that's taking the pictures with these cameras up on the mast. And you can see the little helicopter there, the Ingenuity helicopter, which has been doing its flights. We've been taking movies of Ingenuity's flight from Tempe campus, and that's been just spectacular. But someday the rover will stop working. It's not coming back to the Earth. It's going to be there on Mars. It'll be part of the Smithsonian on Mars, and you can go visit it. So that's going to be a lot of fun too.
Jim, I think the slides haven't been advancing. That's we were on one and it didn't change forward, so we didn't see the last couple pictures. So it still says summer vacation on Mars.
Oh no, it's not. It didn't show Perseverance.
It didn't.
Oh no.
I know, and I know if anybody's going to show me Perseverance, I want it to be you.
Is that? Are you seeing it now?
We see it now. Oh, yep.
All right. Well, I can go. You know what? Let me go back to the old share method. Sorry, I messed it up. I should have just should have just stuck with it. How's that?
Perfect. Fantastic.
Okay. So there's Perseverance. And if you didn't see the tallest volcanoes in the solar system, the deepest canyons, and these spectacular layered deposits that I was talking about earlier, and then I showed that clip from the film, and then said all those wonderful things about the helicopter and Perseverance, which will be a tourist attraction in the future. It's not coming back. You want to see some spectacular, poetically blue sunsets instead of the red sunsets of Earth, the blue sunsets of Mars. The red planet is the place to go. And so I think that Mars is going to be just a spectacular tourist destination. It's farther than the moon. It's going to take some time to get there, weeks to months. Right now, it takes 6 to 9 months with our fastest spacecraft. Advances in propulsion technology will speed that voyage maybe down to the weeks or months time frame within a century or two. Maybe you want to go farther out. Maybe you've got more time. Maybe you've retired and you want to check off all these places in your passport of the solar system. You want to go out to Jupiter and the Great Red Spot, for example. The Great Red Spot of Jupiter, a storm that's been raging since Galileo first observed it in the 1600s with his relatively primitive telescope. He and other colleagues around the early 1600s were the first to spot these kinds of features on other worlds. And maybe you want to see the most spectacular aurora borealis and aurora australis in the solar system. You've heard of the aurora. Some of you may have seen the aurora on the Earth in Alaska or South America. But Jupiter has the most impressive, gigantic, enormous, dwarfing the Earth-sized auroral displays in the solar system. Again, just a nice, beautiful shot. This is not a Van Gogh painting. This is an image from the Voyager missions of the Great Red Spot of Jupiter. Just spectacularly beautiful landscapes, cloudscapes in this case. You saw in the film, the filmmaker imagined a ship that could open its doors to see these spectacular bay windows looking over these scenes, and you can float through, and just what an amazing sight to see, right? Maybe you'll be floating in those clouds, just like on Venus, in a balloon or in one of these lighter than air vehicles that can keep you at shirt sleeve temperature and even shirt sleeve pressure in the atmospheres of Jupiter and the giant planets. Again, bring some oxygen to breathe. But those would be the jumping off points, not for jumping off, but for voyaging either down deeper into the clouds or out to the moons of Jupiter itself. And I've got some slides about those as well. You can watch small comets crash into Jupiter. This happens a lot. Astronomers have seen dozens of these now. The most famous in 1994, when a whole string of comets crashed into the southern hemisphere of Jupiter, producing these nuclear explosion size bright events, and astronomers can predict them ahead of time, and you could be on a craft watching at exactly the right time. Some of the most amazing natural displays of fireworks in the solar system. And then Jupiter has these incredible moons, Io, Europa, Ganymede, and Callisto. Here they are. They are planets in their own right. Ganymede here, the third one, is larger than the planet Mercury. And it has a core, mantle, and a crust and a magnetic field. It's a planet. It just happens to be orbiting another one. These are all planets, I call them. Europa has this thin crust of ice that overlies an ocean. There's a liquid water ocean underneath this icy shell, this icy crust. And you can see that the crust is a close-up from the Galileo mission. Close-up of the icy shell shows it broken up into plates like sea ice up in the Arctic. And those plates move and they rotate and they crack, and stuff oozes up, salty water oozes up from underneath that icy shell because there's an ocean under there. It's heated from below by the heat of gravitational encounters with Jupiter and the other moons. And it's one of the best places that we know of to go look for other forms of life in our solar system. We've never been into that ocean. We haven't seen it directly. We need to get down to the surface eventually and send submarines and other space water submarine vehicles down there, robotic, and then eventually human. You saw some people walking across that icy crust in Eric's movie. And maybe those are scientists who are sending probes down into that ocean to search for evidence of that life. Maybe geologists, volcanologists would go to Io. Io is Jupiter's closest in large moon, and it's the most volcanically active place in the solar system, much more so than the Earth or Venus is predicted to be. It's so volcanically active that there's no ancient part of the surface at all. There's no impact craters. It's constantly erupting onto itself and resurfacing and recovering itself. And the kinds of volcanism that are there are very much like the fire fountaining that you see in Hawaii or Iceland or other places. So what spectacular sights are waiting for us there for not just geologists, but any fans of super impressive natural displays like volcanoes. What about Saturn? You're going to go even farther out. Titan is a large moon of Saturn, and Titan is unique among the moons in our solar system. First of all, it's really big. It's, again, bigger than the planet Mercury, so it's really a planet of its own, but it has a thick atmosphere. It's the only moon with a thick atmosphere in our solar system, and it's about 50% thicker than the atmosphere that you're breathing right now. But no oxygen. It's all hydrocarbons, methane, ethane, propane, those kinds of smoggy hydrocarbon, nitrogen gases in that atmosphere. So again, bring something to breathe. But boy, what's awaiting on that surface is going to be pretty spectacular. Beneath those thick, hazy clouds is liquid. There are rivers, there are lakes, there are seas down there today of liquid on Titan. It's not liquid water, it's liquid hydrocarbon. At those pressures and at those temperatures, only 90 degrees above absolute zero so far from the sun, ethane and methane and propane are liquid, right? You hear the liquid sloshing around inside your barbecue gas grill tank, right, at that pressure. It's the same on Titan, and there are liquid lakes and seas and rivers on Titan that you could go boating on. You could, with the right equipment, go swimming in. Okay, can you imagine going to this place? This is an artistic rendering, but there's must be places like this on Titan. A river of ethane and methane. You could go walk over here and dunk your head in a waterfall of propane. Whoa! I mean, that's on my to-do list, right? I want to go somewhere like that. What spectacular! And then you saw this in the movie, right? Titan is much smaller than the Earth. It's bigger than Mercury, but smaller than the Earth. The gravity is lower. Okay, the gravity is a little bit lower than gravity on Mars. The atmospheric pressure is high. The gravity is low. If you and I were to put on a set of wings, jump off a cliff and flap, we could fly. That's what you saw in that movie. That wasn't some strange, weird winged aliens. That's people flapping wings and flying in a low gravity, high atmospheric pressure environment. We can fly on Titan. I mean, don't you want to go? I want to go. Absolutely. Also see some of the spectacular sights in the sky, the amazing rings of Saturn. Saturn is an enormous planet in the sky of its moon, Titan. Or maybe go visit the rings of Saturn themselves, right? Just billions and billions of icy chunks, some the size of houses, some the size of smoky dust particles, all captured in a flat plane that's orbiting around Saturn. What a spectacular sight that would be. I can imagine a wonderful diner here, a restaurant, very romantic setting with big windows, and all you're seeing is like Lucy in the sky with diamonds everywhere you look. Just really spectacular. That's waiting for us in the future. Maybe you've got a lot of time in your hands. You want to keep going. You want to go farther and farther out there. Uranus, Neptune, Pluto, the distant planets, the distant objects in the far outer solar system. There's lots of them. There's a lot of asteroids out there. There's lots of small planets like Pluto out there in our solar system, many hundreds of which will be discovered in the decades ahead, and hundreds of which have been, thousands of which have been discovered already. And what are you going to do out there? You can go cliff diving. You saw the people in the movie go cliff diving on Miranda. I'll show a still of that in a moment. Go to places like Triton that has geysers. You can go tour the clouds of Neptune or Uranus, just like you did Jupiter and Saturn. You can go skiing on Pluto, and you can choose whether you want to ski on water ice or CO ice or methane ice or nitrogen ice. Different skis, a different kind of give to the skis everywhere you go, and a low gravity skiing experience because it's a smaller planet. But all of these things are possible out there in the distant outer solar system. I mentioned cliff diving, this small moon of Uranus called Miranda. It's only a couple of 250 miles or so across, very, very low gravity. And one part of it shown in this picture from the Voyager mission in 1986, there's this cliff of ice, this sheer 90-degree cliff of ice called Verona Rupes. And it's like 3-4 miles high. And that's what Eric showed in the movie. It's the ultimate solar system cliff diving experience. Get the right spacesuit on, get a good running start, jump over the edge, and you fall and fall and fall. And maybe 15, 20 minutes, you're falling down this spectacular landscape. You're going like 50 or 60 miles an hour by the time you get to the bottom. So there's cushioning, big, airbags and ways to absorb your fall. So you have to be careful about that. But again, you've got the proper guides. They're well trained. They're going to get you there safely. They're going to make sure it's a great and amazing adventure tourism experience, cliff diving on the moons of Uranus. Boy, amazing. Here's an artist's rendering, but based on reality, of the geysers on Neptune's moon Triton. So far from the sun, almost 30 times farther from the sun than the Earth is. The sun is just a dim speck in the night sky, and yet there's still geologic activity there as the sun warms those ices and causes geyser-like eruptions. And then some of these beautiful shots of Pluto from the New Horizons mission that flew by Pluto and its large moon Charon on the top there. Pluto has this big moon that's something like a third of its size. It has 4 other small moons. It has an atmosphere. It has a core, mantle, crust, interesting geology. This is why Pluto is a planet to me and to many planetary scientists who study really fascinating places like this in the solar system. So at the end of the day, maybe you've done many of these tourist trips. Maybe you've just done some of the close to home ones. Maybe you've gone on a farther trip. Maybe you had a longer vacation. Maybe you retired and decided to do a big loop around the solar system, whatever. But if you're like me, you're going to want to come back home, right? Like tourists want to come back home. And that home is our planet Earth, right? And that's what we're made for. That's where our species came from. That's what our bodies, our respiratory system, our vision system, our skeletons, the gravity, that's what we're made for. There's no place like it in the solar system. There may be no place like it in the rest of the galaxy. We don't know that for sure. There are probably other Earth-like planets, but we don't know exactly where they are yet. Although we're finding lots of evidence of planets around other stars. But at least in our own solar system, close to home, there's nowhere like it. There's literally no place like home. Earth is our oasis in space. And that's one of the things we've discovered from 50, 60 years of solar system exploration, space exploration, is there's nothing like it. Our planet is incredibly special. And we are made for this planet. And one of the things that tourists do, of course, you come back home and you tell stories and you expand your horizons and those of others in your family and your clan based on the things you've seen and done and tried and the people you've met and the vistas you've seen. This is part of the tourist experience. Now, if I'm right, in order for there to be a tourist industry and an infrastructure and a market out there elsewhere in our solar system, we will have had to solve some really important problems in sustainability. How do we live on those other worlds where resources that we need are scarce? How do we get resources from those natural environments in sustainable and responsible ways? How do we build infrastructure in ways that are respectful of what we found when we showed up? All of these are problems that will need to be solved by clever people, engineers and scientists and managers, bureaucrats and politicians of the future. I think they will solve those problems. And when they solve those problems, you can bet that those solutions will come back to our own planet, because we have to solve the same problems here. We have to live sustainably on this planet. We're in it for the long term. None of these other places are going to be, permanent insurance policy habitats for the rest of our species. Maybe some of us can go live in the distant future on some of these other places, but the vast majority of our species will be on Earth forever. And so we've got to learn how to sustain this place, how to live better off the land, how to be more responsible and respectful of natural resources and their extraction. And I think space exploration, space travel, space tourism will teach us many, many lessons that we will bring back to make our home planet a better place for the rest of us to live. In that movie, there were a couple of fun quotes that I just want to reiterate to end with, and I really love this one that Sagan made from Melville. "I'm tormented with an everlasting itch for things remote. I love to sail forbidden seas." Right now, a lot of these seas are forbidden to us. They're forbidden by technology that doesn't let us travel out there quickly or safely. But it's just technology, it's just engineering. Solutions will be found, and we will be able to sail those seas. I agree with my idol, Carl Sagan, that's going to be true. And then another one from Sagan himself. Maybe it's a little early, maybe the time is not quite yet, but those other worlds promising untold opportunities beckon silently. They orbit the sun, waiting for us. I think that day is coming. I hope you've enjoyed this fanciful tour. If you want more details, there's a book with that title out there on Amazon or in your library. Hopefully the library carries it. And you can learn lots more details about this place and why I have this crazy optimism that I think that we are destined to be space tourists and experience all these places for ourselves. So I want to do it. I'm going to try to stay healthy and eat well, live long, but it might be our kids, our grandkids, future generations are really going to reap the rewards of all the exploration that's happening today. Thanks.
That was fantastic. I loved thinking about the whole solar system differently, traveling, the future of space travel. I see in the comments here, I mean, the pictures you found too are stunning. So just a great way to think about it. For those of you who are interested, I popped the link to Dr. Bell's book over in the comments. So that way you can just click on it and get to it that much faster. There's only 2 copies left right now, but it will renew. So I think we do have several questions here that I want to make sure we get to. And the first one is just one of mine, going all the way back to Venus and the space hotels on Venus. Is that your original idea? Because I've never seen anything like that.
I did some research on that, and it's actually, there are a number of science fiction books that have been written both about high altitude travel and hotel-like infrastructure on Venus, on Jupiter, Saturn, the other giant planets. It's not hard to imagine, but it has been in science fiction. And, lots of times science fiction becomes reality. So,
science reality, absolutely. Yeah. There's definitely inspiration there for thinking differently. Well, thank you for that. Let me go down the list of these questions, and folks will have to forgive me because I'm just going to read them in the order they are. So we're going to jump around a bit. So the first one we have is, will it be possible to affect the atmosphere of other planets to make them more accessible for humans? Venus, for example, to change the atmosphere somehow. And I'm going to add on to that, should we? Will it be possible? Should we?
No, great question. And what you're talking about is called terraforming, right? It's taking an environment that is not Earth-like and turning it into an Earth-like environment. Is it possible? Sure. It's, again, technology, engineering. A place like Mars, the air is very thin. If you could create more atmosphere by melting the dry ice polar caps, for example, by cooking the rocks and releasing oxygen and other gases that are stored in the rocks, sure, you could do that. It would take centuries. It would represent, the most massive infrastructure development and technology change program ever attempted. There have only been 2 species that we know of so far that have changed the climate and atmosphere of a planet. One is the blue-green algae that did it 2.5 billion years ago. They started creating this toxic, noxious gas called oxygen. And now there's 20% of it in our atmosphere, but it wasn't there before the blue-green algae. And of course, the other species is us, right? We have been injecting CO2 and other gases into our atmosphere since the start of the Industrial Revolution. And we are changing the climate in measurable ways. And it's think about that, right? Everything that we're doing is producing small but detectable changes for 150, 200 years with all the stuff we're cranking into our atmosphere. And the changes are pretty small. They're significant to us, but they're small in an absolute sense. Trying to make Venus a thin atmosphere planet, trying to make Mars a thick atmosphere planet, technologically impossible for us right now. But can we imagine it? Yeah, we can imagine it, but centuries to millennia to try to do that. Should we do it? Should we do it? That's a great question, because people, if we send people out there to inhabit those environments, that's going to become their world, and those what they're used to. It'll be centuries until that environment has changed. Probably a lot easier to find a lava tube on Mars or the moon, and close off the ends and create a shirt sleeve environment in these relatively small spaces. That's much more easy to do, although still hard. But ethically, should we change the entire climate of all of these other planets in our solar system? And can we do it responsibly? Can we do it at all? Right now, those are science fiction questions, but they're fun to think about.
So I think there's an attached question here that just popped up too. Do we have any examples of any systems that we've discussed that could be built for other planets that have applications on Earth as well?
Yeah, I mean, I think we're many of us in Arizona are familiar with Biosphere 2, right? This is an artificial structure designed to simulate that kind of a facility on the moon or Mars. And that was a difficult experiment, right? And there were lots of unanticipated problems that cropped up. And in reality, when people eventually settle on the moon or Mars or whatever and start building structures and start trying to engineer the atmosphere, or engineer pulling oxygen out of the rocks or water out of the deep layers of subsurface, there's going to be lots of problems that need to get solved. That's why we need engineers out there, because that's what engineers do. They solve problems. And so, any of these systems that are designed to extract resources from the mining industry to the chemical industry, all of those are going to be used on other planets in ways that we can't really imagine right now, and in ways that are different, because like mining, so much of mining relies on gravity on the Earth. You go to the moon or a small asteroid where there's very little gravity, you got to reinvent all of that. So yes and no, that's the answer.
Great. We got next a couple of questions here about Mars. Not surprised there. And I'm going to bounce these around a little too. So how was that great selfie that you had, the image with Percy with Ingenuity in the background? How was that taken?
Yeah, same way that Curiosity rover takes selfies, there's a camera on the arm. The same way you take selfies. There's a camera on your arm, right? And you hold the camera up here. How come you don't see your arm in the selfie? It's because you angle the camera the right way, so all you're seeing is like your shoulder, right? The rover does the same thing, just angles the camera the right way so we don't see the arm, but then it points it around like that, takes all the pictures. So it's a very clever, but tried and true, same method to take the selfies that we do here.
So related to that, I know that it's not just selfies coming back. The question here is, what have you been seeing or learning from the images coming back from Perseverance? Anything that you can share with us?
Yeah, so we see these beautiful, we landed in a crater that has a delta in it. There was an ancient river that flowed into this hole in the ground and spread its sediments out, like at the end of the Mississippi River. And we can see that from the ground. We can see those sedimentary rocks. We can see the layers. We've been spending most of the 3 months since landing just checking out the instruments, getting everything going, making sure the cameras are working right, making sure the power system and the communication system and the mobility system, the wheels and the arm that, and we've still got more time to do that checkout. We've been studying the rocks around us. You can go to the JPL website and see all the raw images that we take every day. They come down for the public to enjoy as well. And it's a puzzle. We don't, we're so early in the learning stage of what we're seeing. We don't even know if these rocks are volcanic or sedimentary. Right? Remember your introductory geology, right? There's volcanic, sedimentary, and igneous, right? They're probably not igneous rocks. Sort of rule that out, but there's some that shows some faint layering, but also some volcanic-like features. So we're trying to just get the lay of the land while we're checking out all the rover instruments. Soon we'll start, the checkout will be done within the next couple of months. Of course, we've also been supporting the helicopter flight, totally separate mission, right? Supporting them with movies and microphone recordings. You can hear the helicopter on Mars. That's really spectacular.
I've heard it, actually, that's
this
cool.
low hum, really very low, not this whining like helicopter sound you'd expect. So we've been doing that, but pretty soon we're going to start heading for those delta deposits, which we know are sedimentary, and which is the reason we decided to send the rover there, looking for ancient evidence of habitability, maybe even ancient evidence of life.
That's just awesome to think about. So if I can find it while we're still on, I'll post the link to the JPL website. If not, you can check out our social channels later, and we'll try to post that for you all. Dr. Bell, you also posted the picture with the blue sunsets, but I think we have a couple people who are still curious as to why exactly that happens.
Yeah, so on Earth, right, we have this beautiful blue sky, the sun sets, it turns red. We have a blue sky because we have a thick atmosphere, and it's scattering the sunlight all around, and it scatters the blue light best, the shortest wavelengths of light. It scatters that best. So that's why our skies are blue. And then as the sun sets, the sunlight is going through more and more atmosphere as it gets lower and lower in the sky. And all that blue light is just scattered away. It's gone. It just doesn't ever get to us. It gets scattered back away from us. And so all we see are the oranges and the reds. And that's beautiful. That's our planet. That's what we're used to. Mars is different because its atmosphere is so thin. It's only 1% the thickness of Earth's atmosphere. So it doesn't scatter the blue light. It has dust in its atmosphere that is reddish iron-bearing dust that scatters the red light. And so during a normal day, when there's always some dust in the atmosphere of Mars, it's scattering the red light around. And so you see these reddish, brownish colored skies. And as the sun sets and the sunlight is going through more of that atmosphere, the dust actually scatters blue light better than it scatters red light. And so it sends the blue light forward to us. And so it turns this kind of like the sky behind you, Sari, turns this bluish color as the sun is setting. We think that if there was no dust in the atmosphere of Mars, if there weren't these famous dust storms, if it actually, the wind stopped and all the dust settled out, the skies would actually be black, like on the moon. The atmosphere is so thin. The astronauts could see the stars in the daytime because there's no air at all. And on Mars, it's just the tiniest amount. But if you put some dust in it, it lights up.
That's actually really interesting to think about. Now I'm going to be picturing this moon like Mars, like red on the bottom, black in the sky.
It hasn't happened in as long as we've been exploring Mars. There's always been dust in that atmosphere. So maybe it never clears out. There's always a dust storm.
Always going to be dusty. I know we're coming close on time, but I still want to ask a couple of these last few questions, and some of them might be honestly kind of quick answers. You talked about the thousands of exoplanets that have already been discovered. The question is simply, how many planets do you think are actually in the entire universe?
Whoa, how many stars are in the entire universe? How many galaxies are in I mean, there's something like 100 to 400 billion stars in the Milky Way. There's something like 100 to 400 billion galaxies in the observable universe. So that's how many stars, right?
A lot.
How many planets do that? I think that's like 10 to the 23rd or something like that, right? Some crazy scientific notation number. If each of those stars is like our sun and has 10 to 100 planets, then you multiply that number by 10 to 100, and that's how many planets are out there. Now, how many of them are like the Earth? Well, in our solar system, how many of those 10 to 100 planets are like the Earth? 1. So maybe it's 1%. Maybe the Earth is super special. Maybe the Earth is 1 in a million, right? Maybe the Earth is 1 in a billion. Let's say the Earth is super crazy special. 1 in a billion, right? Crazy lottery ticket. You're never going to win that, right? Okay. Billion is just 10 to the 9th. I was just talking about 10 to the 25th. Right? So even if it's 1 in a billion, there are billions of Earths, right? So the Earth and life has to be truly, fantastically, astronomically unique for there not to be other Earth-like planets, for there not to be other life in the universe. So I'm a total believer that there is other life in the universe, probably even other intelligent life, probably even in our own galaxy. The problem is we're so far apart from each other. And darn Albert Einstein and his speed of light, and can't go faster than speed of light. Communication with other life is going to be ultimately the big problem that we may never be able to solve unless physics and becomes science fiction-y, right? Unless warp speed and all that science fiction stuff which physicists don't really think can happen unless that really can happen. And who knows, maybe we're so ignorant that it's obvious that it should happen. And but until then, it's going to be, hello, anybody out there? And then we wait 10,000 years and somebody writes back, hello.
Hello.
Yeah.
I tried to have the conversation. I was looking at an image today of email speeds. If you were trying to send an email to, say, Pluto, and it would take something like a ridiculous amount of hours, even at the speed that we have now.
10 hours.
About 10 hours, 9.8 hours. So imagine now
Yeah.
trying to answer it back and forth. Yeah, that's it.
So I'm an optimist about life, but maybe a pragmatist about our ability to communicate with it.
Well, like I said, I want to respect our time here. There's a couple last questions here that I did think were pretty fantastic. One of our viewers wants to know, of all your professional accomplishments, Dr. Bell, what's the one thing that you're the most proud of?
Oh my gosh, I don't know if there's one thing. I've been incredibly fortunate, along with many of my colleagues, to be able to participate in these, this is the most incredible time of exploration in modern times, right? I mean, we are exploring the worlds around us, not just our own planet, but the planets around us. And to be able to share that through the internet with so many people in the public, the pictures and the stories, I think that's been the thing that I'm most proud of, and just teachers and school kids and enthusiasts of space exploration, not just in the U.S. but around the world, huge fans of what NASA does. It's one of the most amazing things that we do as a country is explore. We pool our resources. A tiny fraction of our tax dollar goes to do this stuff, and I'm really grateful to my fellow taxpayers for that. And we recognize that comes with a responsibility to pay that back through amazing pictures and books and textbooks and helping our teachers and all that kind of stuff. So that's what's been the best part of it.
Totally worth it. And then absolute last question, what advice, Dr. Bell, would you have for anybody that's maybe on the call today thinking about going into a career in the STEM field, space in general, or transitioning careers even? I want to be inclusive of everybody that's on. Any advice for them?
Yeah, so I mean, maybe I hopefully gave you this impression from the talk. It's not just scientists and engineers that do this. It takes all kinds of people and all kinds of jobs across every sector of job type that you can imagine, even lawyers, to do this kind of work, to explore, to create the infrastructure that will enable space tourism, enables us to go into space and learn things and explore together. So it's not, my advice isn't you need to do that, you need to study math and science. Okay, yeah, if you want to be a scientist, make sure you're good at math and science, right? But really, if you want to get involved in this adventure, what you really need is just passion for exploration, for passion and curiosity, passion for turning the corner and going to a place that's never been explored or seen before. And there are so many ways you can contribute if you have that passion and that curiosity. It'll take you to amazing places in life, passion and curiosity. And as the director of curiosity or whatever, you should know that, right? You tell people that all the time, and you live it, I suspect. And that's what everybody can do. Yep.
Well, and thank you, because I mean, you're oozing passion, and I think you've instilled a lot of curiosity in our guests today. So I wish we had even more time to keep going through the questions, but we are out of time for today, unfortunately. And this has been absolutely an amazing conversation with you, Dr. Bell. I encourage everybody to check out the book, because you're going to want to go back through all the things we talked about today and more. I am absolutely sure of it. And thank you, Dr. Bell, just for everything you do in STEM, for supporting us and helping to inspire that next generation to do all the things that you talked about.
Well, I hope to see you around the Science Center in the not too distant future as the world comes back online.
Absolutely. We are there. We are open. So we can't wait to see you there. For all of you at home, we can't wait to see you at the Science Center as well. Thank you for joining us tonight. This concludes our astronaut virtual series, but don't worry, we always have something more in store for you at Arizona Science Center. So on site, we're going to be opening the art and science of arachnids this weekend. So you're gonna have to come down and see the largest collection of live arachnids in all of North America. Yeah, all those creepy crawlies, they're amazing and pretty, actually, well, it's art and science, so it's a mix of everything. It's really gonna be incredible. But you can always find more science, tickets for that, and more events online at azscience.org. One more time, thank you, Dr. Bell. This is it for tonight. Everybody stay safe, stay curious, and we'll see you all next time.
Take care.
Take care.